Hey, what's going on, everyone? Joe Haynes here, 3D printing application expert here in Atlanta, and that's where we're presenting out of. We got our Form 3L printer here. We actually have the full system just kind of off camera. We're going to be showing you kind of the workflow, start to finish, and we'll be showing the slicer as well to get kind of a good idea of what the SLA printer system is all about and why Formlabs does such a good job designing and manufacturing and providing this system, solving all sorts of different manufacturing challenges. Just a good overview of the system. We can't really get it all on this webcam. But what you see here is on the left, you've got the Form 3L, and then you have the Wash L in the middle, and then over on the right, kind of looks like a microwave oven. That's the Cure L. And so for us, what we did is we set the wash, or I'm sorry, the Form 3L and the Cure up on these stainless steel tables. Just gives you a really good ease of access. And then we put the wash L on the ground because that lid actually lifts up. There's a wash basket that also raises up, so it's good to have some kind of vertical leg room there. And then with those tables, you see we got these shelves here, really good for working space. You'll see here in a moment what we use those for a little bit more in depth. But yeah, if we just come back and look at the Form 3L here, so if you look down at the shelf here, we use this shelf for storing our resin tanks. So that's actually the container that they ship in. So the one on top is Gray V4. It's a prototyping resin, and we actually have that tank loaded in here currently. And then the box that's just below it is Rigid 10Ks. That's a really stiff glass-filled resin. We've been doing some pretty interesting jobs with that material. And you can see it's got an amber window on the top, so that just prevents any UV light from curing the resin that's inside the tank, but also allows you to see if the resin is in the tank, if the tank has resin in it, obviously. But with the system itself, I'd like to show you one thing that we printed here. But before I go into that, what I'm going to do is I'm going to glove up here. So we keep a box of nitrile gloves that we keep right next to our Cure L. Put these on. And then got some safety glasses that I keep very conveniently down here. And the reason why we do this is because resin in its uncured form is toxic. So you don't want it on your skin or anything. In its cured form, it's safe to handle. And then the safety glasses, obviously, you don't want resin in your eye or anything. So just some safety precautions with that. I think I'm going to move over to this side of the printer. So the amber lid here, again, just like on the tank, just prevents any UV light from entering and curing that photopolymer resin. But I can lift this up, and what you guys got going on is a build platform. And that build platform, you're essentially building the part upside down. And so what it's doing is that build platform is lowering into this tank of uncured photopolymer resin, and it's building it upside down. There's a laser unit that slides back and forth on this x-axis, and the laser passes through a clear tank film, and that's what cures the part layer by layer. So what we got here is we got the Cathedral Notre Dame. So it really shows some of the detail in the surface finish that resin printers are capable of. Not to mention, we've got some architectural customers in the area, like TVS. They have some Formlabs printers, and that way they can print some of these highly detailed architectural models, and they can show them to their customers and kind of get their input. But we have a really interesting video that kind of shows animation of how this works. And so what we've got here, we've got the Form 3 Plus on the left, and that 3L was on the right. And inside that light processing unit is a laser. It's a UV laser. It passes through a series of mirrors, and there you can see it's going through the bottom of the tank and curing that part selectively. And it's going to do that layer by layer until obviously you have your full part. And this is actually on the Form 2, so this is the previous iteration, but it's all built on kind of a lot of the same tech. So you can see it auto fills the resin tank, and the build platform descends down. And the clear resin that we have in the tank here is a really good way to show that laser movement. Looks like there's some kind of like rock concert going on inside the tank. All those laser lights flying around. But yeah, so every layer it peels up off the bottom of the tank and then descends back in, and that curing process resumes. Pretty cool time lapse with that. But yeah, so going back to this part specifically, when a part like this is finished, so this part was kicked off overnight. So we kicked it off before we left yesterday, and it was done this morning. It's one of the great things about 3D printers. There's no programming. You don't have to tend to the machine. It's a lot of hands-off stuff. So with this, now that this part is done, what we would typically do is we would take the build platform off. So this piece removes entirely. And what you would want to do typically is take this and then hang it. There's actually a hanger that's made out of the, I believe it's the tough 1500 material, and that's mounted right here on the side. And this allows any uncured resin to drip off into the resin tank. And you can just leave it like this, walk away for like 30 minutes or so, or an hour, or leave it overnight, say. Just let it drip off and just collect as much resin as you can before we go to our next stage in the process. While it's doing that, while it's kind of dripping a little bit here, I can show you just some stuff here on the menu. The printer has locating sensors for various different components in the printer. So you've got a locating sensor from the build platform. That's what shows here. So it's here, it's showing that it's missing, obviously. We just took it off. You've got the cartridges, which are mounted here on the side. I'll show you that real quick. So the cartridges look like this. These are the same cartridges that are used for the 3 Plus. So you don't have to necessarily, if you already have a 3 Plus and you want to upgrade to a 3L or vice versa, you don't necessarily have to buy like unique resin cartridges just for that system. And so down here at the bottom, you have a bite valve. It's kind of like the mouthpiece to a Camelback water bottle. And you have a little finger that comes in and squeezes that when the printer recognizes that the resin level in the tank is running low. So that's a very convenient system. And up on top, you have your vent cap. So the vent cap, it kind of looks like the top of a shampoo bottle. And you just pop that open, and that just allows the resin to flow more easily. Inside this area, there's a load cell, so that's what's determining how much resin is left over. And there's also a RFID chip on the resin cartridge. And so here we can see how much material is left between the two cartridges, the left cartridge and the right cartridge. So we're running about 500 mils between each. Just go back to the home page. And then the resin tank is a consumable. And so that just tells you how much lifetime you have left. We printed 146 hours with that resin tank, and we got 152 days total with resin. And I believe with the gray material, it can go to like 600 to 800 hours. So we've got quite a long ways to go here. Lastly, so down in here, you've got the print queue. So in preform, which is a slicer, we'll talk about preform here a little bit later. But in preform, you can actually upload a job just straight to the queue. Say you've got your printer on the other side of the plant, and you just are like, well, I need to like double check some stuff with the resin printer before I kick the job off. In that case, load it to the queue, walk to their side of the plant. You can just do your double checks and then start the print while you're there in front of the printer. All the maintenance is tracked in here. So a lot of it is done by layers. Some of it's done by time. So we've had to clean the optics just a few times since we've had this printer. It's based off every 10,000 layers. I believe Formlabs said that like 90% of all print failures are a result of dirty optics. So it's really important to follow this procedure here. But you have other maintenance options as well, and some utilities for replacing certain components. But yeah, so that's all there is to it with this. What I'm going to do now is I'm going to say that this Notre Dame model has dripped resin enough. And what I'm going to do is I'm going to take the build platform off here. And, well, hell, I'll go ahead and show you some of the detail here. You can see lots of really intricate details. These rose windows actually are through holes. So the inside of this model is hollow. yeah, really, really nice detail here. But yeah, you can see there's a lot of like uncured liquid resin on this build platform. You can see it kind of dripping down the side. So that's where that wash process comes in, helps wash that uncured resin away. I'm just going to close the hood of the Form 3L, and then I'm going to load this into our Wash L. And so the nice thing is that you have the option to remove parts from the build platform in this condition, and you can just stick them straight into the basket. Or you can see these nice outriggers here. These are actually spaced apart enough so that you can stick the entire build platform, just mount it right in here, just like that. And so once we have it loaded, what I can do is on the screen, I can select start. So we got a 10-minute wash time. I'm going to go ahead and click start here. You can see the lid automatically closes. And inside that wash shell, there are 2 impellers that help agitate the isopropyl alcohol. So that's the solvent that we use to remove that uncured resin. It's recommended to fill the wash L with at least 91% concentration or purity isopropyl alcohol. The reason being is because the higher the purity, the more effective it's going to be at removing and washing that uncured resin off your part. So we buy 99% pure. And the convenient thing is that there's a solvent monitor that's at the bottom of the wash L, and it's monitoring how much uncured resin and contaminants are inside the IPA. And once it reaches 10%, you have to then recycle that IPA or get it picked up. I think we have some content here to share on that. But yeah, this is just a brief video. The wash may or may not finish by the time this video or this webinar ends, so I just wanted to kind of showcase this. So you can see the countdown here is complete, and it automatically raises your part out of the wash solution. At this point, you'd want to let the part dry. You could put a fan on it because for the next step, the cure, we want to make sure that we don't have any IPA can kind of cloud the surfaces. Now, in terms of recycling your IPA, there are various methods. There's some industrial solutions that use distillation to essentially heat the IPA. It condenses, and then it drains out as a purified liquid. And so there's solutions like from Sidewinder. They have a popular solvent recycler. Or you can have it picked up by a hazardous waste facility like Clean Earth is a local one here. So you have that option. What we can show now is just briefly discuss the Cure-L. And so the Cure-L, this is going to be doing is it's going to be preheating your part to like 60 degrees Celsius for about 5 to 10 minutes or so, depending on the material. And then what it's going to do is it's going to bake that part in UV light. And it's going to do that for like 30 minutes to an hour. And so that's just going to bring your resin print to its optimal mechanical properties. And so we actually just finished curing some parts here. You can really start to see the likeness to a microwave. You got the turntable and all. But here we have this really nice, I guess it's 1/2 of a power drill housing. You can really see, kind of like with that Notre Dame model, you can really see the surface finish there. Very smooth, almost looks like an injection molded piece. So that part is cured. And then we also cured this little peg jig. So it's a little bit of a tolerance test here. So it goes from, these are offsets here. So you got 0, 0.01, 0.02, all the way up to 0.18. And then you can just insert this and figure out, okay, what are some of the, how precise is the machine and all. So you can see it's kind of a friction fit down at 0.02. And you get up to like looser fits at 0.08. So much finer tolerances than say on like a FDM printer. I believe we have a really good video to share that covers the removal of parts from the build platform. So after the part has finished washing and it's finished drying, there is a jig that's mounted. It comes with the Form 3L system, and it's mounted on this edge of the table. And what you can do is using this long, thin blade, you can go in and scrape that part up off the build platform. It does a really good job here. Formlabs also has recently come out with a version 2 of their build platform, which has a spring steel sheet and eliminates the need to do this process. Even with gray, which is a pretty easy material to remove, the build platform 2L makes a world of difference, especially with some of the stiffer materials like that glass-filled rigid tin kit I mentioned earlier. But once you peel this part off the build platform, it's ready for the curing process. And so in this next video that we have here, we're going to show just very briefly what that curing step looks like, because it's really basic. So over there, you can see that we have the gray V4. That's the material that we printed this in. We have that material profile that's loaded. So the cure has all the material profiles from Formlabs. That's preloaded because there's different preheat cycles. There's different cure cycles for each material. And so it's just a matter of placing it on that turntable, closing the door, and then just simply hitting start. So it's just undergoing its preheat phase right now, and then it goes through the UV cure in about like 5 to 10 minutes afterwards. Now, in the next video, we have just showing the support removal. So you saw with that part, we just cured that part with the supports on. And by doing so, it helps keep things dimensionally stable, because you can, if you don't cure it with supports on, you can have a little bit of warping that can happen inside the cure. So I like to leave the supports on. And you can see just removal of the supports is really, really easy. Just with my bare hands, I can just pull all the supports off. It's really important. I mentioned wearing safety glasses when dealing with uncured resin. Obviously, this is a cured part. I'm still using the nitrile gloves because I was just working with the washell earlier in this clip. But I am wearing safety glasses in this video because when you remove those supports, they really tend to fly and fling around, especially when you use the flush cutters. So definitely recommend safety glasses during this step. But a set of flush cutters are included. So yeah, that's all there is to it. Now what I'd like to show, this is kind of our demo table where we have the variety of different materials that Formlabs provides. Obviously there's a fairly fine demarcation between the SLS, the SLS parts and the SLA parts. So from the resin side, obviously the gray materials here, like what we printed Notre Dame in, really great for prototyping. They're kind of like a PLA equivalent material for those of you familiar with FDM. But then you move on to some of the different colors of the standard resins. You've got clear, there's black and white available. We don't have any black, but white. In fact, this is a pretty interesting piece. This is an architectural floor plan, and you can actually see down in there, there's chairs, there's rungs for the table. It's really, really fine, and that's thanks to some of the finer layer heights you can get with these standard resins. But beyond that, you also have your engineering resins, and this is kind of what Formlabs is really well known for. Their engineering resins are pretty impressive. So you've got like high temp materials, which have heat deflections around 238 Celsius. You've got your line of durable, and so durable is this translucent material, and then your tough, so this is like a polypropylene equivalent, and this is like an ABS equivalent material. a lot of uses in many manufacturing spaces.
I think, Joe, I think these parts, it's really hard to understand just exactly how many different types of materials are supported on the SLA platform. Formlabs, in a lot of ways, they're an additive manufacturing company, but they're a material science company. They develop a lot of polymers and come up with some really fantastic applications. Can you tell a little bit about changeover? So if you were running a material, how would you get that switched over to another material? Like you have the gray and the rigid 10K?
Yeah, that's a really good point, Marcus. Specifically about the material science bit, because when it comes to SLA printing, material science is really the critical point of SLA printing. And with FDM, it's kind of more hardware. There's more moving parts. There's just less moving parts with SLA. And I'd be willing to bet that Formlabs materials department is probably one of their best funded departments. They seem to come out with new materials, like 2 or 3 new materials every year. But yeah, just in terms of material switchover, so we saw that there were 2 different resin tanks that we have. We have those on the shelf just beneath the Form 3L. Um, each tank is used for each material. So whenever you want to switch out to a new material, it's simple as just switching out your resin cartridges. So there's 2, if you recall, from the Form 3L, and then switching out your resin tank. And the tank, like the cartridges, has an RFID chip that programs that tank to that material. So it's really simple to switch over. A lot of SLA printers that build not inverted, but kind of right way up. So printers, say from like 3D Systems, they use a ton of resin, and the material switch out is really involved. So the inverted style has that benefit going for it.
And we've got a lot of different materials that are really kind of focused towards certain applications, right? The draft gray resin, it prints a whole lot faster than any other resin, meaning you can get parts out really, really quickly with decent performance on the materials. Then you've got kind of a gray resin, right? That's more standard. Gray Pro, that's much more durable. Some of the more flexible ones, right? Didn't they come out with a brand new full silicone material?
They did, yeah. And around that same time, they also released their Alumina 4N. So it's a ceramic resin. So it prints on the printer, and then there's a separate debind and sintering kiln purchased third party that will get it to that those ceramic properties. Pretty wild.
You said the rigid 10K, that's extremely strong, rigid components, but you can do a lot with that beyond just a plastic part, right? Electroplating and stuff like that.
Yeah, right. So we have a prospect that we've been doing a lot of electroplating for. We don't do the electroplating here, but we provide the printed part in Rigid 10K, and they get it electroplated by a third-party company, and they've been really satisfied with the results. That company highly recommends Rigid 10K for electroplating. And you can also do things like injection molds. So here's like 1/2 of a injection mold here, and we have customers that are have shot pressures of like 1,000 psi. They're running these through thousands of shots, and just before the mold needs to be replaced. And so within 1,000 shots, you can have like 3 or 4 or more of these printed in that time, and so you can totally eliminate your downtime. So
Yeah.
preform is the slicer. This is what's communicating between CAD and the printer itself. And preform is just local on your computer. And so I'm going to kind of show 2 different parts. One of them is the cathedral that we printed. So you can simply open this part, just accessing it through your file explorer. And so there was the model. It was downloaded from a digital file repository. And we scaled the part up by 1.5 times just to really show kind of the scale and the size of the Form 3L, not without using too much material. We could go bigger. But this model was actually designed for printing in mind, which is really convenient. because there were no supports that were needed to print this part. And so it's hollow on the inside. The angles as we taper up to the roof on the inside is all at angles to which we do not need supports. So they're at 45 degrees or so. I think this model is intended for either SLA or FDM printing, but it's going to print a lot better on an SLA. There's some details that just won't quite show up on an FDM printer. And so I'm just going up layer by layer, just double checking to make sure that there's nothing unusual. And then over on the right, you can see that print validation pane. So that is showing if there's any kind of concerns with this part during that might happen during printing. So you've got supports. Are there areas that need to be supported? Are there cupping concerns, which are areas that can produce a vacuum and cause the wall of the part to blow out? And then you can see that white seam line that runs up the ridge line of the roof. So that seam line is a result of the Form 3L actually having two lasers. So the Form 3 Plus just has one, the 3L being just a larger unit, and with certain parts being at a certain height will require both lasers to cure. So there'll be just a seam line, and you can place that a little bit strategically, like in this example. But right now I'm just going through, I'm running the print time estimate. So you can see it's going to use a little over half a liter of resin and take about 14 and a half hours to print. Now, just above that, you can see that we have the option to choose the resin that we're printing in and to choose the layer height. So we've got the whole different variety of materials. You can see the range of materials Formlabs produces from, say, flame retardant materials, flexibles. There's that Gray Pro that Marcus mentioned. High temps down to the glass-filled rigid materials, very stiff and strong, to like the ABS equivalent tough line of materials. And then down below that is where you can choose your layer heights. So gray has, because it's a prototyping material, has the ability to go down to 0.025 millimeters for some of your really, really fine features and most demanding applications. So once we're satisfied with that, we just click that orange button over on the left. We select the printer. So Able Koi is the name of our printer. Those are provided to us by Formlabs. And then now you have the option to either add to queue or print now. Print now we didn't have as an option simply because this print was running at the time of this recording. But that model is really simple as a setup. What I'd like to show is a model that maybe is a little bit more complex. And it is a bottle that we modeled for a prospect. This prospect does a lot of blow molding. And so we wanted to show that you can print a bottle and make it look like it's been blow molded or injection molded. And that way you can show it off as a prototype. You can show it to customers, see if they're satisfied with that specific bottle geometry. So what I'm going to do is I'm going to orient this part, and what I'd like to show is if I orient the part so that the mouth of the bottle is placed directly on the build platform, just like that, you're going to see this yellow outline appear, and that is what's called a cupping warning. So over in that print validation pane, which I'm going to highlight here in just a moment, you can see cup detected. So again, preform is letting you know of these errors before you print. They're all Formlabs is all about best success. So there's not a lot of guesswork here, which is really nice, especially for me because Formlabs is my first experience with resin printers. So it's been a very very nice learning process. But you can see that there's two suggestions provided by Preform. You can either add vent holes or you can reorient the model. Now I don't want to add vent holes here because I want this to be a watertight body. So the intention is that once I finish printing it, I could fill it with hydrogen peroxide or water, and that way you can kind of feel the weights and ergonomics. So instead, I'm going to reorient the part. And so you can grab those arc handles and kind of orient it that way, or you can enter in a fixed value, as you saw I just did in that orientation window. I set it to 45 degrees, about the y-axis. And then now I'm going to jump into supports, right? So you can see the whole bottle highlighted red. It says I need support material. So I just unchecked that RAF label option since we don't really print that much. I don't need the part to be labeled. And then I'm changing the support density down by like 20% and the touch point size down by like 10%. And I remove the internal supports check because I don't want any supports generated on the inside of that bottle. So I'm going to click auto generate all. And this is a great thing about preform is it's going to auto generate. It's going to produce those truss supports everywhere I need a support in this area. So it takes just a moment. And here's the finished product. So you can see that there's a lot less supports than what you might be familiar with if you have, say, hobbyist resin printers where peel forces are very high. So Formlabs has a patented low force stereolithography technology, which produces very low peel forces. So the peeling off the bottom of the tank is very low. So we don't have to have as many supports, and we can also have a wider range of materials. And so as a best practice, what I like to do is just drag up the layers and see if there's anything kind of strange going on, which you can see I identified, well, we have some supports actually going through the mouth of the bottle and supporting the inside region of this. And so I could simply go into the edit menu and I can just unclick those support pips and hit apply, and it's going to update with the changes. So those are now gone. Typically, the unsupported overhang angle is about 10 degrees, so 45 degrees is plenty fine. It's one of the reasons why you don't see a lot of supports kind of off to the right. And now what I'm doing is I'm just double checking some of the regions down at the very start of the print. So kind of like, FDM, the first several layers of your object are really critical for print success. So it's a really good idea to kind of focus on these areas. And checking out some of the islands. So you can see where you have parts of the bottle printing and they're not attached to the rest of the bottle. And so I'm just double checking that those regions are well supported. And I'm just stepping my way up, making sure all those areas are good. And I don't see anything of concern, just making sure that opening of the bottle is well supported as well, which you can see it is. Preform does a really good job at identifying these minima and these overhangs. Even that small chamfer right there gets a little bit of support. That chamfer is at a 45-degree angle. The bottle's at a 45-degree angle, so it's a direct 0-degree overhang. And you can see it puts a line of supports on that feature. So we're all good. I'm happy with this. Again, the Notre Dame model was printing at the time, so it didn't have the ability to print now, but I do have the ability to add it to the queue. The last point I wanted to make, so because the mouth of the bottle is pointing towards the build platform, and you have to imagine that this whole image is inverted as it's printing, the area up at the top of the bottle is actually going to contain some uncured resin as it prints. But the reason I have to actually print it this way is because if I were to try to turn it to allow uncured resin to drain out the mouth, now you can see we get that cupping error again. So in that case, I would have to add vent holes to alleviate that issue. But the great thing is that printing it in the orientation we did, we can simply hang it on that hanger that I showed earlier, and that's going to help drain any resin inside. And we actually have that bottle just right over here. I can show what that looks like. So we actually kept the support structure. I think that's showing up pretty well. So that's essentially how it printed. And so you can see how when printed upside down like this, as these final layers are printed, you're going to have a little bit of captured resin. But by simply hanging the build platform up, you can allow all that resin to drain out the mouth. So it's really not a big deal. And yeah, so that just comes off. We actually modeled those threads to mate with the cap that we use for our isopropyl alcohol. So this is actually a working thread feature. And so even though we had thread pips that were on these threads, or I'm sorry, support pips that were on these threads, the material is super easy to sand. And so it actually doesn't do any kind of damage or dimensional deformation to the thread, and it still works. Still works really, really well there. So yeah, that's that finished product. And yeah, looks like it's been injection molded. But yeah, that's all there is to it with that. The model finished washing. So right now I'm just letting it dry before I peel it off. but yeah, that about covers it for the SLA system.